At Northrop Grumman, innovation isn't just an idea. It's a way of life. The value of performance. Northrop Grumman.
It's a real pleasure to be here, and if I understand it correctly, my task is in the next 20 minutes to get you so completely jazzed about mathematics that you're going to love it and follow it for the rest of your lives. And that is clearly an impossible task. But fortunately, two things are true. One is that I have not had any breakfast today, and two is that I am like the White Queen in Alice in Wonderland. Anyone know the reference? What does the White Queen do before breakfast? Believe 6 impossible things. So I believe that I can get you so excited about mathematics in the next 20 minutes. So how in the world could I possibly do that? Well, presumably, I would need to show you the most amazing thing in mathematics. That's like my only hope. But here's the problem. There's way too many amazing things in mathematics for me to have a hope of doing that. How did I make this slide? I went on Google Images, and I just typed in succession the name of about 7 or 8 different sub-areas of mathematics: group theory, topology, knot theory, fractals, geometry. These are the images that you get. A lot of those areas you haven't even heard about yet, and that's the crime. You need to learn more about math. Math encompasses so many things. You need to learn about the breadth of math. How in the world am I going to choose? I had to choose something, so what I'm going to choose today is math modeling. What the heck is math modeling? Math modeling is something that you do almost every day without even realizing it. Here's an example from those people who are all okay, lumberjacks. Which tree can I cut down in the forest to give me a board 10 centimeter wide? Well, it's kind of obvious, right? I'm just going to go out, I'm going to measure around the tree. Hopefully we all know what the circumference of a circle 10 centimeters in diameter is. Think, think, think. 31.415926535. Oh, those, okay. My ruler's not that accurate, doesn't matter. I need about a 31.4 centimeter tree, so I'm going to go out there, I'm going to measure it with my little tape measure. If it's big enough around, I'll cut that tree down and give me the boards I want. Now, I've just made a math model. And what does that mean? I simplified things down to a mathematical structure that I could reason about and make some conclusions. What's wrong with what I did? Trees aren't circular. Show me a cross-section of a tree that anybody's ever cut that's a perfect circle. They're not the same girth. They're not the same amount around all the way up. So where am I going to put that measuring tape? The bark has thickness. I don't get boards out of the bark. There needs to be some thickness to the part that's 10 centimeters wide. If the diameter is 10 centimeters, I can't really get a 10 centimeter wide board from it. And you're going to lose something when you're cutting it, and so on and so on. There's a million ways that I've messed up. But that doesn't matter, because that basic model, a tree is a cylinder. If I cut it, I've got a circular cross-section. Gives me enough information. And this really is how they decide what trees to cut down when they're cutting, when they're doing selective cutting in a forest. And okay, you have to take some of these things into account, make some adjustments. Maybe you don't take 31.4 centimeters. Maybe you really got to do 37 centimeters. But that's how you do it. This model has power to give us conclusions, give us information about the world. Okay, so now you know what math modeling is. So let's do some. And we want to model something interesting. Remember, my goal here is to get you jazzed up at mathematics. We got to model something interesting. What is the most interesting thing that we could model? Well, I don't know about you guys, but I think you guys are the most interesting things we can model. So we're going to model you today. And so what's one of the most important things about each and every one of you? Well, if this is a talk to get you excited, get you feeling great about mathematics, well, I think one of the most important things is how you're feeling. Now, remember I said this is a math model. In a math model, we like throw away all the details. We try to think, what's the most simple characteristic? How can we boil things down to something that we could have a hope of analyzing? And so we're going to just boil it down. There's only 2 ways. For the rest of the day, there's only 2 ways every one of you can feel. You can either be ecstatically happy, or you can be desolately sad. Now, you will find in the chair underneath you, I hope, if all's gone well, 2 sheets of paper, a blue one and a pink one. And at those times during the talk when you're ecstatically happy, you're going to hold up a pink sheet. And at those times during the talk when you are feeling kind of sad, you're going to hold up a blue sheet. And we're going to start by just having everybody hold up the sheet that comes closest to describing the way you are right now. And I can show you all what that looks like here. And wow, that's pretty good. We got a lot of happy people, some people that just aren't quite feeling it, but there you go. That's what we all look like. Okay, you can put them down now. We'll be using those more. We've now decided how we're going to capture your state, how you're feeling, what way you are being right now. So what are the interesting questions that we can ask? What are the interesting mathematical questions we can ask once we've captured that? Well, now we're going to be interested, we know what your state can be, and we're interested in how you behave, how your state changes, what influences whether you're ecstatically happy or desolately sad. And of course, again, that's a really complicated thing. There's probably lots of things that feed into your emotion. You know, did you see your kitty cat this morning? Did you have your favorite breakfast cereal? Did you have no breakfast at all? That's why, anyhow. So, again, we're going to have to make some simplifying assumptions. And here is the most important key simplification of the first model that we're actually going to study and execute here today, which is that there's only one person in the world that matters to you. That's right. Your entire well-being, your happiness or sadness is entirely based on the state of only one person in the world. And amazingly enough, by incredible coincidence, that person happens to be sitting immediately to your left. Okay? So right now, whoever is nearest to you on your left is the only person in the world that matters to you. Whether you are happy or sad depends entirely on that person. Now, if you happen to be sitting all the way on the left, we'll just shift that around a little bit. The only person that matters to you is the person directly in front of you, by which I mean the person who is leftmost in the row in front of you. Okay? So for you, young man, the only person in the world that matters to you is Teo Gray, which is probably true after the wonderful talk that he just gave to you. And Teo is the only one in this room with free will. Okay? So that's going to come into play in just a second. All right. So there's only one person that matters to you, but it turns out there's different ways that person can matter to you. They have two possible states, ecstatically happy or desolately sad, and you could react to that in a bunch of different ways. In fact, there's 4 possible behaviors here. And you can see the possible, so the person on your left is either happy or sad, pink or blue, and you can react in one of these 4 possible ways. And we could name these 4 possible ways. There's that one on the top left, that's the eternal optimist. Happy no matter how that person feels. I actually don't care about you, I'm just happy. Or in the bottom right, the eternal pessimist. I don't care how you feel, I'm just sad. Then the more interesting ones are love in the bottom left, right? If you love somebody more than anything else in the world, if they're happy, you're happy. If they're sad, you're sad. That's the love behavior. And finally, in the top right, schadenfreude. That maybe is a word you haven't seen before. That is joy in someone else's sadness. So not the nicest thing, perhaps, but this is your neighbor is, if your neighbor is sad, you're happy about that. A little weird. And if your neighbor is happy, that makes you sad. Okay, so just for the sake of exploration, we're going to all in this room for the next about 30 seconds behave with schadenfreude, okay? And as I said, Teo is the only one with free will. He can hold up either a pink or a blue. As soon as you see that one person who matters to you, hold up either pink or blue, react with schadenfreude. I'm going to capture it on film. Okay, go. I see some things up. We're going to go here to the other screen, and we'll get this going on here, and we'll see what's happening, okay? Remember, as soon as you see that one person in the world who matters to you, hold up everybody should be holding something up. As soon as you see that one person who matters to you, hold that up high, okay? Very good. And look at this. This is amazing. What did we get? We got a checkerboard, all right? So that's actually pretty cool. With something so simple as schadenfreude, you too can generate a 600-cell checkerboard. All right, so we've gotten somewhere already. Okay, so, and you can imagine what the other sets of behaviors will develop. In fact, all the other sets of behaviors will develop everybody in the room being identical. So that's kind of boring. All right, so this was kind of cool. We got a checkerboard, kind of almost out of nowhere. Very little apparatus. But it's still, okay, checkerboards, I mean, if you've played checkers after a while, well, actually checkers is an interesting game, but nevertheless, what else is going on here? So when you've started with a model, it's a very simple model. The next thing you want to do is say, well, how can we make the model more realistic? How can we make the model more interesting, more complicated? What's the simplest thing we can do this model? What if 2 people influence you? And I'm going to let you guess which 2 people that's going to be for you today. Yes, it's the 2 people immediate to your left. And this time, the 2 leftmost columns in each row, we're just going to randomize those folks. We're not going to worry about any kind of rule. We're going to randomize those folks in a minute. Now the 2 people immediately to your left are the only 2 people who can influence you. Your state of happiness or sadness just depends on the 2 of them. Maybe they're kind of like your parents, but okay, let's not go there. All right, so now there's 16 behaviors. Okay, and that's kind of complicated. I put all the behaviors up here on the screen for you. But it's not as all bad as all that, because if we look, we can actually recognize the 4 behaviors from before. They're the ones where you, in reality, you're ignoring the person 2 to your left. You're only paying attention to the person immediately to your left. And we have the eternal optimist, love, schadenfreude, and the eternal pessimist there along the diagonal. Kind of interesting they come along the diagonal. And actually, these show up in 2 other places. Schadenfreude and love also show up in 2 other places. This is where you have those feelings toward the person 2 to your left, and you're really actually ignoring the person immediately to your left. So those are, we've already seen those. Those aren't anything new. So there's really only 10 new behaviors, and we can name them all here. I don't have time to go through every single one of the names, but just you can see what they mean. The conflict avoider is happy when the 2 people to his or her left match, and sad when they're not in agreement. They don't want that kind of conflict. Okay, so there you go. That's the conflict avoider. There's somebody that's mostly an optimist. They're happy unless both people are sad, then they get sad. And then there's Eeyore. Eeyore's okay. Eeyore gets along fine. He's okay, except when everybody's happy, when both people are happy, he just can't avoid being sad. Okay? It's just somehow, when everybody's happy, he's got to put a little damper on things. Otherwise, he's just fine. That's the Eeyore behavior, and that's what we're going to try now. And here's what we're going to do. If you're sitting in the first 2 columns on the left here, you're going to put up red, that is happy if the number of letters in your first name is odd, and sad if the number of letters in your first name is even. So if you're in the first 2 on any row, first 2 to the left, put those up now. And as soon as you see the 2, no. The rows continue across only those guys over there. So right. You're gonna be reacting to the people over here and so on. And now as soon as you see the 2 people immediately to your left go up, follow the rules there and put your thing up. Okay? And I'll go to the video here. Right here, okay, and we'll see what's going on here. These patterns are starting to develop. Here we go. We can see the patterns developing there, and they're going across. And here it comes across. And now you can see this is definitely not a checkerboard. Okay, the patterns have got to propagate the gap here in the center. You need to have the 2 people to your left. Okay, you can see they're starting to slowly propagate across. And now we're getting some action over here. We're getting happiness and sadness. Okay, very good going across there. And as this starts to develop, you can look along your row, okay? You can look along your row and look at the pattern of, you guys need you need the rule maybe, huh? Yes, it's a little confusing without the rule. There's the rule again. Sorry. It's just tricky with both. If you've forgotten the rule, then there's the rule. Okay, very good. So, So anyhow, if you look along your row to your left, what are you going to discover? Okay, I think we're good now. Very well done. What are you going to discover? You're going to discover that every row was a repeating pattern. In fact, every row eventually gets into blue, pink, pink, blue, pink, pink, blue, pink, pink. Okay, so that's more complicated than a checkerboard. We got some new interesting behavior. But Okay, so periodic, that's good. It's kind of like, rational numbers. When you divide a regular fraction, you always get a repeating decimal. So we've kind of discovered the repeating decimals of this world of happiness and sadness. So, but still, in periodic, it's like you understand it really quickly, what's going on. So if you want to make that more interesting, well, maybe we could depend on the 3 people to our left. Or maybe we could depend on the 4 people to our left. Well, to make a long story short, which I have to because I have a short time to get you really excited, you always get periodic behaviors. Doesn't matter how many people to your left you depend on, you're always going to get periodic behaviors. Here's the case where you can make a tiny change in the model. Just a tiny change in the model. And it makes a world of difference. Now instead of having to depend on the 3 people to your left, which would only give periodic behaviors, now your happiness state depends just on the 3 people most immediately in front of you. So look ahead of you, see who is most immediately in front of you, and take the person to the left and the right of that. Those are now the only 3 people in the world that matter to you. And we're going to start, in this case, with the front row. And the front row is going to be entirely sad, except that one young gentleman all the way over there on the right. That's you. You're going to be the only happy person in the front row. And now there's 256 different rules. So I'm not going to put them all up on the screen. But I'm going to give you just one. And this is called Wolfram Rule 110. Point of interest, Stephen Wolfram is the other co-founder of Wolfram Research, along with Mr. Gray. And now, whenever you see those 3 people in front of you go up, put up according to this rule. So over here in the section where you got all blue, and all you guys put up all blue over there too, okay? All blue, except for the ones over here that are going to be pink by one of these rules. And now wait for it to come to you, but as soon as you see the 3 people in front of you have their hands go up, follow this rule, okay? So yeah, there's going to be a lot of blue here, a lot of blue over here, but near this kind of boundary, wait, because you have to wait until all 3 of the people in front of you have got their signs up, and then you can put yours up. And you got to follow these rules here, focusing on just the 3 people in front of you. I see some pink over there, and now some pink should start. I'm not going to put the video up this time. Some pink should start to rise. We're seeing some pink over there. And we want to try to do this as quickly as you can. As soon as you see the 3 people in front of you all have their things up, put yours up. And now it's going to start to propagate and head its way back. Okay, and it's heading back. And now what you can see, if you're over on this side, I guess the happiness isn't spreading over here too much. But what you can see here is that there's this irregular pattern of pink here. And again, to make a long story short, what I can tell you is that we could have an auditorium infinitely deep, and this pattern would never once repeat. It would go on forever, generating new arrangements of sad and happy people. And not only that, but this rule is sufficiently powerful with just what you see on the screen so that we can set up an arrangement of sad and happy people in the front row here to be able to compute any function, eventually far enough row in the back that any existing computer can function. I'm going to leave you with that. There's so much more to find out about. What I've really been showing you about something called cellular automata. Take a look, and it can be one of those things that hooks you into math. So I hope you're feeling the math. Thanks for the opportunity.